Hi there. So in this series of videos, we're going to be focusing on the process of importing a model of a CNC machine, preparing the model, rigging the kinematic setup for it, defining the working ranges of said model, applying work coordinate systems to it, working through all of the finer details of the final setup of the model, and finally bringing it into ENCY as a working CNC machine for programming. So to start with, we need to look at importing a CAD model of our CNC machine, which is not something we can do directly in MachineMaker. We need to make use of one of the utilities built into MachineMaker to be able to do so. So to find this utility, we click on this menu at the top left, and we go to Utilities, and then we click on Simplifier. Simplifier is explicitly designed to be able to process CAD models and to take out any extraneous details that we don't need from them. So I am going to click on Import here, and I already have these models downloaded and ready to go. These are VF2 mills as supplied by Haas. I'm going to grab this one because it doesn't come with the extra 2 axes that are a bit redundant to what we're aiming for at the moment. And I'm going to open this file now. So it does take a minute or so to process the file as well, because it's going through all of the geometry and preemptively preparing itself for things that it can highlight in some of the utilities built within Simplifier to be able to grab and extract details that are unnecessary. So each time you import a model, it will go through the process and parse the entire model, checking through for these things. However, as I say, this only takes a short while, and we've now cleared this particular hurdle. So first things first, you can see that this particular model has been built in a CAD package that exchanges the Z-axis around. So we are going to need to rotate this, and the tools for doing so are exactly the same as in the model space within ENCY. So I'm going to click on the spatial transformation tool here, and I'm going to rotate it around the x-axis in 90 degrees, and I'm going to click on OK. So once that's finished processing, we now have the machine facing the correct way. But as we can see, there's quite a few extra details on here that aren't really all that relevant to what we're working with. We don't need the pendant, we don't need things like the side doors or the chip chute or any of that sort of stuff. So we can go through making very, very quick sort of executive decisions about what's necessary on this machine now by getting straight into the geometry hierarchy here. And again, because of the way that Haas build their CAD models for their machines, it's all pretty nicely structured for us and hits most of the notes that we need straight off the bat. So having played with this model a little bit myself, I can safely say we do not need any of these things here. So we can grab those straight away, and that's all good. As we can see, all it's doing is it's highlighting the different options of tool changer, something to do with the flood cooling system. We've got the chip auger as well, so we don't need these. So I'm going to right click and delete these. I'm also going to grab a few of the other modules that are in here that are kind of redundant and surplus to our requirements. And that should, I think, be everything. So right click and delete these. And very, very quickly, we already have a much, much lighter model to work with. So realistically, that's done the bulk of the work that we actually need. We do also have a couple of automated tools built into the Simplifier as well, which are generally better used when you've got much more detailed CAD models than this. So say, for example, you're importing a new spindle into your machine. A lot of the time when you get the detailed CAD model of, say, a spindle or a motor or something similar from a manufacturer, that CAD model will be to manufacturing standards. So it will have everything in it. Individual bearings, every single bolt and nut you're going to see, even down to the stators and the windings within the motors themselves, which is completely redundant for our needs. We don't need any of that interior stuff. So the tools that we've got allow you to strip a lot of that out. And we select the model now just so we can see that it's live. We've got simplified geometry here. which, as you can see, the model starts out totally grey, and this is processing through all of that information that it previously grabbed. And we can now change any of these slider settings to be able to grab more of the model as we go. And I appreciate we're not really showing a great deal of changes here, but that's because most of this model's actually pretty clean and pretty well simplified anyway. But each of these red elements that comes up as we change these slider values are things that it will highlight and delete for us if we allow it to. I'm not going to in this instance because it's unnecessary to do so. We also have a similar tool for closing holes in faces, and you can see it's slid all the way over to the right by default, and it's trying to select things like the window apertures for stuff to close as well. So you've got a lot of granular control on that, right up to very large sweeping changes as well. But again, as I say, I'm not going to bother running it on this model because the model's already pretty clean. Anyway, I'm now happy with how this looks, so the next step is going to be to import it to MachineMaker itself. And to do so, we're going to click on the Send to MachineMaker button. It's very helpfully labelled, bit ambiguous that one. We're going to leave the current base defined as the bottom front left because it's as good a place as any for this. It's only describing the actual world coordinate of the machine itself, so I'm not worried about it. So I'm going to click on OK, and we're going to wait for the new dialog boxes to open up where it tries to import to MachineMaker. And here we go. So import mechanism geometry. This allows you to define the mode in which MachineMaker operates, as well as the kind of mechanism that it is you're going to be working with. I tend to work with robots quite a lot, so quite often the assembly mode won't be set to milling machine, it will actually be set to robot cell. But as you can see, by clicking on that edit button, this forms a drop down menu now and gives you the option to make those changes. So we're going to go back to milling machine, and we're going to leave the mechanism type as milling machine because we're not dealing with individual pieces of equipment, nor are we dealing with the multi-tool head here. So I'm now going to click on add, and that pretty much brings us to the end of this first video. In the next video, we're going to start taking a good look at all of these settings over here for being able to define the various kinematic axes in this, as well as setting the limits and the motion ranges available to us. I shall see you in the next video.